Okay. Please let me know if it's back. So I just reduced the resolution a little bit. So I hope that will work better. And I hope you're still all there. Not sure. Please just let me know if it's working again. And now it's not saying it's great. So I hope that's true now. Yeah, that's awesome. Like as if Multimorphic knew it, it's perfect for streaming to have like cycling lights. And besides that, it's pretty cool, to be honest. So yeah, that's basically that's the P3-Roc if it's happy. The P3-Roc if it's happy, then it's cycling. So yeah, what I'm going to show you is like basically four things. It's the P3-Roc itself. Then the SV16, that's the switch import board, which is already here. And then there's like a little bit more. There is the PD16, that's this board. And then we got like the PD LED, which originally has been like an LED board only for parallel LEDs, but by now it has like gained a lot of functionality, and in my opinion, it's the most impressive board, like feature-wise. It has really a lot of stuff. So yeah, what I got here is like the P3-Roc, which is like that's the main controller here, right? And what it actually does is it interfaces via USB. Yep, it interfaces via USB. It's a USB-A, so it's like a really stable connector, so it won't go off below your machine. So like a lot of boards, like they got micro USB or mini USB. I would say this USB-A is a lot more stable than that. You need to feed it like power, 5 volts power. You can either use like this ATX supply cord here, or you can simply connect it with a Molex connector like I did. And now then, usually you cannot see this. Let's drag it over. So usually you would only use like those few connectors here. And the rest is probably unused in almost all machines. And the reason for that is like that this board has been originally made for the P3, which is this awesome machine from Multimorphic with a large screen, where you can then basically play on the screen and it can show stuff on it. And what they put here is yeah, right, in Alien it has been an issue, right? And yeah, this is basically for those burst optos. So they got like long range optos which go over the whole playfield, and then they can track the ball on this large screen they got in their machine. So that's basically the purpose, at least the initial purpose, for all those connectors here. And initially, they also haven't been usable for homebrew, so they actually sold the board, and all you could use was actually really that, and the rest was basically unusable for you. And there's like yeah, but this changed, and now you can use those inputs and outputs. So actually, those are like 64 inputs, I think, and 64 outputs. They do not have drivers, as you can see. So like they're like digital outputs. So you could connect like a FET or a transistor here and drive anything you want. And especially if you want to control some logics, that's super nice. And you could also inputs which have no protection whatsoever. So they are similar to like, I don't know, like the Open Pinball project, which also does not have any input protection. So this is similar. I wouldn't use those below a playfield, to be honest, but if you just got logic input, that's super nice. And what I did here is actually I added like a switch here. So like this is just a small switch where I can press, and that is connected to one of the inputs. And if I can show you like the MPF shell, the console, then you can see that once I press it, like MPF registers this switch input. So it's like 64 inputs. It's a lot. The same for output. So what I did is I actually connected like one output here. That's basically this red wire. And here I connected like one output to an input, and now I can pulse the output here, and you should see. Does it work? No, maybe it doesn't. You should see that the switch is actually pressed. I think I tested it, but maybe not. Yeah, but that's basically both are logic power levels, so you can safely connect those if you want. And now I can basically create this loop. There's more on it. So so what's also on there is like an I2C. So on this GPIO connector here. Yeah, I think it's on the GPIO connector. It's on aux at one of them. Those I don't know actually. I used that earlier, but so at one of those there's actually an I2C. So you can, for example, connect a servo connector. And I actually did that earlier before the PD LED actually got support for servos. I had an I2C servo connector connected here, but like not every I2C, but the common I2C commands are supported, so you can control like some additional driver board for like the backlight in your machine, for example. That would be an option. That's super neat because just added functionality which is there. There are also some GPIOs here. I think like 6 or some are usable of those for like jumpers. So if you want to input like an ID here for your machine, like a serial number, that's also available in MPF. And then there's like an accelerometer on here. I think that's here. Oh, that's the USB, right? No, that's this one, the small one here. I think that's the accelerometer. So it basically can determine the level. You can, to some extent, use it as tilt. So that's like a very flexible board, I would say. It's super nice, and yeah, that's super cool. Additionally, like there's those burst Optos, and you can use them also. Like I got those here. So this is basically an adapter board, which would then connect like to one of those headers. So basically, you take like a ribbon cable and connect one of those headers to this board, and then you got like 8 headers here, and those headers go to those burst Opto senders and senders and receivers. Those are identical, so you can use them either way. Just connect them, and then you got like a long range Opto, which is really nice. So this is not like, it's not like your normal Opto, like 10 centimeters. It's more like, I don't know, 1 meter, so like 3 feet something. There's a lot possible. So those are really long range. They technically work like the sender on your television, right? Like the infrared sender, the pulsed infrared sender on your television. So those are super neat. And you can have like 64. I think you can have 64, and it will actually sense each between each. So right, if you got 10 here and 10 on this side, it will measure the beam between each of those. So this is actually really a matrix of long range stuff. So yeah, thanks for joining. Have a great evening. And yeah, that's awesome stuff, to be honest. I didn't use them. Just played with them for developing in an MPF. So, but I mean, I tested them. They work, but I didn't use them yet in my machine. So that's an awesome feature, to be honest. And I guess that's what this board does, and in my opinion, it does really a lot, especially since they opened up all those additional inputs and also documented how GPIOs work and so on. And that's all available in MPF. Just open the documentation. It's documented there how you can use it. So that's this. We now got this this SV16 board, which is the board there. So this board, it gives you like 16 inputs. It's I mean, it's a boring board. That doesn't mean that it's a bad board. It's an switch import board, and it got like 2 banks of switches here, 8 switches on each side. Basically, I got like revision, I think it's revision 1, and there is like a newer revision which also has like 1 more connector on those for power. So this one has ground and then 8 inputs, and the new one also has like I think 5 volts on it. No, it's even 12 volts. It's 12 volts, so you can power Optos directly from this connector. That's a nice addition. They also added like a ground pin here, so that has been my critic for the system when I bought it. That actually the bus which connects like the P3-Roc here to the SV16, that this doesn't have an additional ground here, so it only has plus and so like this like a differential bus, and it has like a signal and an inverted signal. And at this board, as you can see, it doesn't have an additional ground. And technically, that's better. It's not needed especially for those short wires here. But if you run longer wires, it gets more reliable with like with additional ground. But they added that. That's great. So that really rounds the system, in my opinion. Yeah, and I guess like in most machines you got like 4 SW16 boards, so you got like roughly 64 inputs, like maybe 48 will work, but you usually got 1 in the cabinet for like your flipper finger switches and some cabinet switches, and you might not even have 16 there, so maybe you only have 8 in your cabinet or 6. And then you basically lose a few in the cabinet, and then you need like 48 below the playfield roughly. That's what I would guess what you need. So as I built a head-to-head machine, head-to-head pin machine, I bought like 10 of those boards. We actually used I think we actually then used 8 of those, so we never had 10 in the machine. Yeah, but they work fine. You basically set an ID here on this header, and then MPF can actually basically iterate them. So that's what you can do with MPF. Let me show you. You can do like MPF hardware scan, and then it will say it's a little bit small here. And it would say that it found one SW16 board here with ID 4. That's because that's like the 3rd dip switch is on, so that first is 1, second is 2, 3rd is 4. And it has 16 switches, and that's just basically the firmware and the device type. So I think that's probably different for if you got revision 2 of the board. Technically, this so the P3-Roc does not know how many drivers it has. So those drivers, which I will show you next, those are actually, I mean, the P3-Roc drives them, but it doesn't know how many there are, and so MPF also doesn't know. So it just trusts you that you configure them correctly. So yeah, that's how this works. If you look at like the MPF configuration. This looks like this. So basically, you got in the hardware section, you configure your P3-Roc as platform. Pretty standard. You always do that. Then you say like the driver boards are PDB. That's basically these boards, like those node boards. It's called PDB. And that's what you have to configure there. And then you can configure. I will show this later. For switches, there's like a format which is MA4, so address 4, bank 0, switch 0. So that's what we got here. This is basically ID. That's ID 4. And then we got bank 0 and bank 1. And then 0 to 7 on each of those. So that's the numbering. For the P3-Roc, like here, we got like this direct 24. That's the direct switch 24. That's on jumper and header J9. So that's how that works. But you can look this up in the configuration if you want. Same as valid for a lot more stuff. I will show you in a minute. So next will be like the drivers, and the driver board looks like this. So this is like a PD16 board, and again it's connected with a serial bus. It has 16 drivers, which you can see here. These are basically the drivers, and then it has basically two banks. So bank 0, bank 1. It also, which is really nice, it has like fuses on here. So you can feed it voltage here and then get the voltage out here so that you can fuse each bank. That's really a nice feature in my opinion. It gives you like additional protection below the playfield, and it helps with fault isolation if something burns. So like legally you only need like this power input board, which you usually have with one fuse, but it's nicer to have more fuses below the playfield, because then you can use smaller fuses, and if a fuse burns, you know which bank actually caused it. Otherwise, I mean, if the central fuse burns, then you have to check all the coils. That's super nice in my opinion, and a great feature here. Like, it's literally a lot of drivers on one board. So I would guess in most machines you use 1 to 2 boards of this. So because like a modern Stern machine has also only like 12 drivers usually, and you can have 16 with one board. And if you got 2 boards, then you can just connect like anything. It's so many drivers, so that you can like put flashers on them, for example, or like your GI and stuff. So that's nice. It's a super robust board. Again, the addressing works via the stip switches here, and besides that, there's not much to this board. It just works. This bus is basically a chain, so this bus goes out here, and this board is powered by 5 volts, and the chain basically goes on to the next board. And the order of those boards doesn't really matter. So you can put like ID 2718. Just do not put the same ID twice, but otherwise it doesn't matter in which direction you put those boards. Like there's actually a watchdog here. It's D14. If you connect this board and this stays on, this usually means that either your bus isn't connected correctly, or like you swap the wires. That's also, I mean, it's harmless, but that also turns off the watchdog basically, or touch on. So the bot stays off, the watchdog LED is on. So as soon as you start MPF, it should go off. If not, that's usually like a wiring problem. If we look at like the configuration, this looks like like this. So again, same syntax. It's like address 3 because this board has like the first 2 dip switches on. So that's 1 plus 2, 3. And then this is bank 1 here. And that's basically driver 3 and driver 7. Also, I got like this direct driver here. That's the one I showed in the beginning. So that's on the P3-Roc directly. Then that's the PD LED. And furthermore, we got like the PD, that was the PD16. Now we got the PD LED. And the PD LED is this board, my personal favorite board. So again, it's connected by the serial bus here. It feeds like 5 volts here, and it's originally made for parallel LEDs. So it can drive like 64 parallel LEDs, and that's that's a lot of LEDs. If you like go with RGB LEDs, then it's 24 LEDs, I think. So then it's not that much anymore. So then you need like, I don't know, 3 boards or 2 or 3 boards of those for your machine. But like this parallel LED stuff gives you like a lot of flexibility. For example, you could drive those segment displays which are BCD encoded with like, I think, 4 outputs of those of this board. I guess, yeah, it should work with 4 outputs per digit. So you would like need quite a few, 16 or something. But that would drive like this segment display here. Or you can also have like single LEDs like I got here. So I connected those to some, so I can turn them on here, check it also works. You can also turn them off, right? So you can directly connect an LED. It will drive them with like a current of 20 milliamps, which is super nice because you do not need like an additional like current limiting resistor or something. It will just do it right. So you could also do like 2 LEDs in a series. That would also work. So basically that has been the original board, and for parallel LEDs, I personally wasn't so much of a fan of parallel LEDs because you just need a lot of wiring for that. But they improved this board with the version 3, which is it's handwritten here by Jerry on this board because he hand flashed it for me. But like this is a version 2 board with a version 3 firmware. I think if you got a version 2 board, you can send it back to them and they will flash it for you. As you can see, the version 2 board already has like this additional ground here, which I talked about earlier. And with the new firmware, it has like a lot of new features. So actually, it has 3 chains of serial LEDs, and that includes like the WS28 series, and it also can do like this LPD 8803 LEDs, which are also nice. So it can do both. I'm not sure, but I think even both at once is possible. But basically you trade in like some outputs, but not many. So like if you use serial LEDs, then you lose like 2 parallel LEDs. And you can also use steppers with it. So if you want to use a stepper motor, you need like an additional driver such as this one. So those are like available for $1 or $2. And yeah, you can connect your driver there, and you need like 3 wires from this board, or like 4 with ground, from the PD LED to this driver, and then you can drive a stepper with this driver. And you can also control servos here. I did like a stream on servos like a week ago, but I just connected one here. So that's the wrong key. So the right key is this one. So we can actually turn this. It works. Super nice, super simple. It's not like an advanced servo controller with acceleration ramps or stuff, But like if you just want to control up to 12 servos, this board has you covered, and it will only like cost you 12 LED outputs, which you usually would have. So that's like super nice. You can even have features like, so now it's like it's the servo is pushing, so I cannot move it. It's complaining. Can even disable the servo here, and then that's the wrong direction. Then I can move it manually, right? And if I turn it on again, you can't move it. So that's super nice. Also, what we can do, so yeah, that's basically this board, and that's all what I wanted to show you. Like initially, I didn't connect serial LEDs. Just believe me that it works. I also didn't connect steppers. Please just believe me that it works. If you want, we can do it, but it would take like a few minutes. Yeah, so that's, if you have questions, feel free to ask. We can try stuff if you want. One more thing I did is like I connected some inputs. Yeah, like one more thing, I forgot. For those lights. So that's basically the number syntax is similar. We got like 4 is the ID of the board, again with dip switches. And then it's like that this is the LED number. That's basically the channel syntax. And what we got now with parallel LED is that MPF does not know which color channels exist on your LED. So if you got an RGB LED, you have to tell it like the red channel is this number, and then I could say it like the blue channel is number 440. Because I mean, it doesn't know that like an RGB LED is the first channel is R, then G, then B. It could be R, B, G or something. So you have to explicitly tell it which numbers, which channel, so which numbers on which channel. And that's what I did here. Like I mapped those 3 LEDs, and then add some light player to turn them off and on. Same is also true for like servos. It's again the ID of the board. It's 4. And then it's this it's 0, like the first servo output, which I used here. Yeah, so on in the P3-Roc section, you can also like configure your PD LED boards, and there are certain features. For example, I can tell it how much if you want to know the details, check the recording of the previous stream. I can tell it like the minimum value of the servo and the maximum value of the servo. It's like pulse times. You probably want to change this if your servo isn't turning around completely. Mine didn't initially, so I had to change those values a little bit because it's a really cheap servo and it's not very standard conformant. But that's not unusual in servoland. And you also like have to tell it that the first servo is actually a servo output. So I can set like, it's not auto-completing here, but I can do it like for use servo 2 for 1 true. That's also then the next servo is also a servo. And I also have to enable serial LED here. So that's valid for all of this stuff. And if you want to know what's possible on which pin, that's a little bit confusing because it's not like super simple. We kind of got this in the documentation, but if you really want to know it, it's in the documentation of this board, and it's basically all on this J8 header. There you can see that like what's on with which header, and that's like a lot of stuff, right? So here you can have LED 73 or servo 1. Here's servo 0, and then here you can have servo 3 or stepper 1. So if you enable the stepper 1, you lose basically those 3 here. And for you cannot even see, you cannot see my mouse, but you use like you lose like 7 to 9 pins, 7 to 9. For stepper 0, you lose 12 to 14. And for servos, you just lose 1 pin each. Same for serial LEDs. yeah, you can have like both types of serial LEDs at once. With the LPD 880X LEDs, you lose like 7, 8, or 9 for one chain each, and for WS28, that's 17, 18, 19. So like this is the overview of all those options which you can enable in MPF also. And just keep that in mind. But it's like a lot of stuff, and you just have to figure it out once per board and then connect the stuff, and it will just work. So that's on the PD LED board. And finally, what else do I have? Yeah, I connected some switches here, so I can just show you that it's actually working. So I put those switches here, so I can press the switch. Oh, sorry. Or I can press the switch, and those are, and they work. Let's put it this way. And I also like connected some input-output pairs, so I can pulse a driver and I did it wrong. I can pulse a driver, and those are connected in a loop. So I connected the driver here from. I connected the driver here on this board to those drivers, because I mean I didn't put power on it. Do not ever do this if you have high voltage on. And I connected those here. So what I can now do is like I can trigger event 1, which pulses the first coil, and that triggers this switch test 3. And I can also do this with test 4. And the reason why I do this is that it allows me to like benchmark the system. So I pulse the coil, and then we measure how long it takes for MPF to get the switch which is connected to the switch event for the connected switch. And that's actually something we can run. And yeah, so MPF hardware benchmark is what it does. That's this. Let's do it. And it will actually measure the latency of the hardware. So now I have to tell it that I'm really certain and that I know what I'm doing and that I turned off high voltage. We will do it. And now we'll start measuring. It will pulse the coils a few times. And then it will give us like some latency measures or measurements. And we did this with the Open Pinball project a few weeks ago. And I also did this earlier for this system, so I know that it works. And now we get like the results, what it actually gives us. And it's not so surprising. It's like, so without the stream encoding, so without CPU usage, this is roughly like 16 milliseconds. So we get like the mean latency, now like, yeah, 18, 19 milliseconds. And like this, like it varies a little bit, right? It's because of the CPU load. Without the stream, it's like 16 milliseconds. That's kind of the expected USB latency. It can be tuned, but it's always like a trade-off between throughput and latency. So like for Open Pinball project, we got like something like 7 or 8 milliseconds. It's all fine. So like if especially with this system, you get like we get like timestamps with the switch hits. So even if we got some latency here, we will not lose switch hits because they're timestamped and MPF can handle those. But we can see like how well this works. We can also see that rule latency is really low. It's like below 1 millisecond. And we can see that if we try to pulse for 53 milliseconds, it looks like on average the measured pulse is a little bit longer for some reason. Might be related to like debound settings on the switch. And for 33, it's so similar. It just looks like there's like some huge variations here. And for like a shorter pulse, it's a little bit lower. Yeah, probably debounds related. And yeah, so that works. It's reliable. It has like some stable latency. In my opinion, it's a great system. And yeah, you can do like a lot of stuff with it. So it's like a proven production system. Like Spooky uses it in the TNA, and also I think in Rick and Morty. And there are also some American pinball machines, I guess, with like the P3-Roc. So that's really a proven system. You can buy it. It definitely works. Even got better over the years slightly. So yeah, that's from me. Thanks for joining in, guys. If you have questions, please ask. Otherwise, I wish you like a great evening or afternoon. And yeah, see you soon. Keep on hacking and keep on making pinball. I'm out.